Okay, 2 point charges Q1 and Q2 are separated by a distance of 3.5 cm as shown in the figure 1 below. Okay, determine the direct magnitude and direction of electric force that Q1 exerts on Q2 and also the electric force that Q2 exerts on Q1. Okay, good. So first of all, let's take note all the units. Okay, here is micro Coulomb. Okay, all these are micro Coulomb. You have to change to SI unit Coulomb, right? And this is centimeter. You need to change to SI unit meter. Okay, and then the questions ask for magnitude and direction. Magnitude and direction. So you have to calculate the magnitude, the value, and also the direction. That means you need to draw the vector. Yeah, draw the vector force. Okay, you need to draw and also determine the direction. Okay, put it in words. So this question asks for the force. Okay, electric force. So force refer to F. Yeah, refer to F. Okay, the force. Q1 exerts on Q2. So who experienced the force? Who experienced the force? On Q2. Q2 experienced the force. Okay, so I can put it as like F12. That means which is F1 on 2. Okay, so 2 who experienced the charge 2 who experienced the force. Okay, whereas for the question B, also ask for force, but this one is Q2 on Q1. So who experienced the force? Charge 1 experienced the force, which is F21. Okay, F21, which is F2 on 1. Okay, you charge 1 experience the force. Okay, so first of all, let's do the question A. Let's do the question A. Okay, now I think I need to draw some diagram. Okay, I need to draw a diagram to show you. Okay, so I have drawn the diagram here. Okay, the diagram for question A and also diagram for question B. I want to show you the direction of the force, okay, which is meant by each question. Okay, so for A, electric force that Q1 exerts on Q2. So you just draw the force on Q2, yeah? For question A, he just want the force on Q2, not on Q1. So you need to draw the force on Q2. Yeah, be careful with who experienced the force. Okay, Q2 experienced the force. So the force is on Q2. Okay, it's on Q2. You need to draw the force on Q2. First of all, we know that before we solve this question, let us go to the basic. Okay, electric force. Okay, is experienced by 2 charge. If it is unlike charge, positive, negative, they attract, attractive force. Okay, but if you have like charges like positive, positive, negative, negative, they repel each other. So the force is away from each other. Okay, so if unlike charge, they attract. If same charge, I mean the like charges, same sign, they repel. Okay. So for this one, this is a positive, negative, unlike charges. Okay, it is I can say this is a unlike charges. Okay, so they attract each other. Okay, they attract each other. Attract each other. So this is the electrostatic force. Okay, so so for question A, which force is it? Is it this force or this force? Which force for question A? On Q2. On Q2. So this is the force. The second one. This is the force. Okay. on Q2. So I can say, in other words, to be more exact, I can write it like this. I can write it as this force should be F2 2 on 1. Okay, F2 on 1. This one is F1 on 2. Okay, F1 on 2. So so for question A, it is F1 on 2. Yeah, 1 on 2. So it is on Q2. Yeah, on Q2, which is this one. This on Q2. Okay. So he referred to this force. He referred to this force. So which is F1 on 2. This is what it means by F1 on 2. Okay. Positive, negative charge, they attract each other. So for question A, it referred to F12, which is this force. Yeah. So don't draw the force on Q1, because for question A, he just want the force on Q2, which is on Q2, which is F12, F1 on 2. Okay, this force. For question B is F2 on 1. F2 on 1 on who? On who? On 1. On 1. So he refer to the charge 1. Yeah, to refer to charge 1, which is this force F21. Okay. So let's draw it. So for question B, it is F2 on 1, which is this one. F2 on 1, which is F2 on 1. Okay. He referred to, so for question A is referred to on 2, yeah. For B is on 1, on 1, on 1. So this is F21 and this is F12. Okay. So all right. So A is this force F12. B is this force F21. Okay, on 1. This one on Q2, this one on Q1. Okay. So now so we already know the direction. This one is to the left. For question A is to the left. For question B is to the right. We already got it correct already. Yeah. The direction correct already. Now we want to find the value. How to find the value? Just use the formula KQQ over R square. Yeah. KQQ over R square. Let's find out. Okay. F1 on 2 is K. Which formula do we use? Do we use a KQQ R square or QQ over 4 pi epsilon naught R square? I think this one KQQ R square is more preferred because just one constant value K, whereas this one has 4 pi epsilon naught, a bit longer. So don't worry, this K and epsilon naught both can be found in the list of constant. If you look at the list of constant, this K value, okay, let's find the electrostatic constant. Where's the K value? Where is the K value? This is our list of constant provided in the exam. So where's the K value? Is this Boltzmann constant? Is it the same as this one? 1.38 exponent negative 23? Is it that one? No, it's not that one. K is 9 exponent 9. 9 exponent 9. 9 exponent 9. Yeah, 9 exponent 9 is not 1.38 exponent negative 23. No, this one is used in semester 1. This one in okay. This one, sorry, what happened? Yeah. So okay, never mind. So this one is semester 1. The time you learn about the when is it you use about the kinetic theory of gas, thermodynamic. You use Boltzmann constant. Boltzmann constant. So this, don't use this one, this value. So where is the K value? This one, constant of proportionality for Coulomb's law. This one. So it's 9 exponent 9. Not the 1.38 exponent negative 23. So this one is also joule per kilogram, about energy, you see. This one is charge, Coulomb. Coulomb. So this one is the correct unit, you see. So 9 exponent 9 is not 1.38. So be careful, use the correct value of K. the k is at the bottom here. Yeah, the value of k here, yeah, 9 exponent 9. So this value, and then if you want to use epsilon naught, the other formula epsilon naught, you also can find the epsilon naught over here. Permittivity constant epsilon naught 8.85 exponent negative 12 farad per meter also can, yeah, that's the permittivity of free space. Okay, so epsilon naught and also the k value at the bottom here, constant proportionality for Coulomb's law 9 exponent 9 is over here. So you can get this value from the list of constant. Okay, make sure you use 9 exponent 9, not the one with 1.38 exponent negative 23. This is for semester 1, and 9 exponent 9 is for semester 2. Okay, so this is the one, the value. Okay, 9 exponent 9, we got the value. Okay, let's write down the formula first. The formula kq over r square. Okay, let's write it down. So this is kq1 q2 over r12 square. Okay, because this is between force between 1 and 2, charge 1 and 2, so this one q1 and q2. All right, now let's substitute the value. K is what's the value again? K, the value is 9 exponent 9, not the 1.38. Be careful, it's 9 exponent 9. Okay, 9 exponent 9. And then Q1 is what's the charge of for Q1? The charge for Q1 is 85 microcoulomb. Oh, you need to change to coulomb, the SI unit. Micro is exponent negative 6. So it is 85. Okay, 85 exponent negative 6 coulomb. Okay, and then some more Q2. Q2 is negative. Oh, you have a negative sign. Be careful. This one, okay, still remember what I told you? Okay, ignore the negative sign. When you're talking about, when you calculate the vector, the magnitude vector like force and electric field, you ignore the sign in the charge. Ignore the sign. Okay, only when we talk about potential and potential energy, the scalar quantity, then when you do the calculation, you must have the sign on charge. Okay, so for vector like force and electric field, the charge, you ignore the sign. Yeah, for calculation. Okay, so remember this. So for this one, for calculation value, the charge, I know that this Q is negative charge, but this one you ignore negative sign, for Q2, for charge, yeah, for Q2. Okay, ignore the negative sign. So you just put positive value. You just put positive 50 microcoulomb. Okay. So it's 50 exponent negative 6 coulomb. Okay, we don't want the negative sign. Ignore the negative sign for Q2. Okay, although it is a negative charge. Okay, because we just want the magnitude, the value. The magnitude is always a positive value, isn't it? Magnitude modulus is always positive value. So that's why the charge, we don't want to put the negative sign. I don't want to put the negative sign. Okay, now let's continue. Put it our distance. What is our R? What is our R distance between the two charge? 3.5 centimeter. So centi is negative exponent negative 2. So you need to change to meter. So it is 3.5 centi. Centi is negative 2 meter. Okay, what am I missing out? The square. Don't forget you have the square. Many students forget the distance need to square up. So you forget the square. You need to square the distance. Don't forget to square the distance. Many students missing the square for distance. Now you calculate. So you have 9 exponent 9 multiply 85 exponent negative 6 multiply. Okay, let's calculate. Yeah, let's calculate. And then exponent negative 2 square. Okay, what do I get? I got 3.12 exponent 4 Newton. This is a force, so it's Newton. You need to mention about the direction. Okay, force on Q2, because attractive force, positive, negative, they attract each other because opposite charge, opposite sign. So they attract each other. So this force is to the left. You need to say direction is to the left. Or you want to say towards, or you want to say towards Q1 also can. Yeah, you want to say to the left also can. You want to say towards Q1 also can. Okay, so that's the directions. And then how about for question B? For question B, also the same. You modulus, because we just want the magnitude, F21. So when you want to find magnitude, modulus, or always positive value, because always positive value, your this one Q1 Q2 also Q1 Q2 Q1 also the same. Yeah. So again, you also ignore the negative sign. Yeah, this one, the charge Q2, although it's negative charge, but we just ignore the negative, because it's modulus, you know, it's modulus, so it's all positive value. I want all positive value. Okay, so you see, these two formula is the same. Yeah. Anyway, this is action reaction force. You know, these two force, they are action reaction force. Yeah, these two attractive force. Yeah, they unlike charges, they have this attractive force and attractive force. So these two forces, they are action reaction force. Action reaction force, that means they are equal in magnitude, but opposite direction. You see that? Equal, they are equal in magnitude, but they opposite direction. One is to the right, one is to the left. They are opposite direction. Equal magnitude. So what I can say, this one is equal. F21 is actually equal to F12. It's actually equal to, but it is it's actually equal. The magnitude is the same, equal. So I can say they are the same value. Yeah, the same value. I no need to calculate, because they are same force. They attract each other with same magnitude. Although we know that Q1 is a bigger charge, Q2 is a smaller charge, but these two forces, they are equal in magnitude. They attract each other with same magnitude. They attract each other with same strength. Okay, we don't say the bigger charge attracts stronger compared to the smaller charge. Smaller charge attract weaker. No. Yeah, they both attract at the same force, although they have different charge. Okay, because they are action reaction force. Okay, so they have the same force. So A and B have the same magnitude. Okay, same magnitude, but opposite direction. For B, on Q1, its direction is to the right. Okay, I can say it is to the right. I can also say in other way. I can say towards Q2 also can. I say it towards Q2 also can. Okay. So is it correct? Let's mark our answer. 3.12 exponent 4. Yeah. Yes. This one is to the left, and this one is the same magnitude to the right. Yeah, both are correct. The magnitude and direction are correct. Anyway, I can write this, you know, F21 and F12, both of them, they are action reaction force, equal in magnitude but opposite in direction. So I can write like this, equal in magnitude, negative. Negative means the opposite direction. Yeah, negative means what? Means it's opposite direction. Okay, in terms of magnitude, they are equal, but in terms of the direction, they are opposite. That's why I have a negative sign to show the opposite direction between these two. Okay. So that's all for these questions. Yeah, make sure you look at the question. He asks force on which charge. He is asked force on Q2, then you only draw the force on Q2. Don't draw the force on Q1. Like this one B question, force on Q1, so you just draw the force on Q1. Don't draw the force on Q2. That's all. Bye bye.